differential equations, and of course physics and optics and all. QT03 talks about programming and also some more physics there. QT03 is here, right? And presently quantum computation has started. That is okay. That's also there. That link will also be there. QT04 course is not there. Now you may be wondering what is this QT01, 02, 03. This is actually coming from AICTE standard syllabus which was created. Okay, this is the syllabus. Right, so this is the model syllabus. This PDF is available. For that you just have to go and type AICTE model quantum syllabus on quantum in Google. You will get this PDF, right? Yeah, PDF madam will share. The quantum links also madam will share. So please you can see, material is free. Okay, what is needed is our time. Our time is more precious than quantum time. Quantum time is very precious, but we are not able to get time. So what we have to do is you have to steal time. So before you sleep, you spare 1 hour every day. Or my colleagues are there who are married with kids, especially madams. So they are telling before we sleep, we are giving 1 hour to quantum, right? Or getting up early morning and before everything starts, 1 hour they are giving. So everybody is sacrificing, and let me tell you, at least in the 1000 participants in each course, at least 100 people are above 55, age of 55, 100 people, right? I have interacted with some of them. First I used to write, no, you are not done that. Then they used to call me. Then I used to see their picture. Sir, you are in the picture. They say, yes, I am in the picture. Then I say, sir, you are elder to me. Yes, I am elder to you. So like that, many are elder to me in the course. So they are doing now, okay, out of interest, not that they want to earn or something, but they are doing out of interest. So please take it, these things, material is available, content is available, students are willing, government is pushing, right? So maybe take time. Don't expect that within 3 months I will do something. You give 1 year, right? National Quantum Mission is not going to go anywhere. 6,000 crores they cannot spend like that, right? Okay, next year by July you will be fully confident. You will run some simulations, you will run some projects, some BTech projects, you get it done, some your own PhD if you are doing, or if you are guiding PhD student, you get something done, right? Quantum machine learning, some of the tools we earlier didn't know. You know, when I was talking first time, my colleague told me penny lane. When I heard penny lane 3 months ago, right? You heard now, right? Only difference is 3 months. But that fellow started working on penny lane, his students they took, and then now he is taking session in this quantum course. He is in IIT Ropad, Santosh Parthi, Telugu boy from Visakhapatnam, younger to me, right? So he is now ready to take a national level talk on quantum machine learning, because he is very good in quantum machine learning. He has applied it to quantum, right? Now, but he has also not written the codes. His students have written the codes, but he has told them, I want these results. They got the results. He is able to speak, and because he is able to show within India, we are able to run the codes. No, many of you will now start thinking like this, quantum machine learning. I did not get PhD students last 3-4 years, right? Because I was selling network security, dark web, no, blockchain. Nobody wants to do, right? They know I am very good supervisor, very soft and very nicely he will get it done, right? They know, but they are not. They want AI. So last time I started putting AI word before and after, AI forensics, something like that I put. Then also nobody came. This time I put quantum machine learning. I got 2 students. They want to do on machine learning only, something on machine learning. Oh, quantum, okay, we will learn quantum, right? But machine learning, AI, right? Anyway, that's good. So these are some options which we can look at. So please, so these are the courses, and let me tell you why I am going there is because these courses is what our state government AP also wants to do. So these are the courses, right? Mostly this is the syllabus. We may modify. State Council of Higher Education may modify. This PDF will be given to you and it is available online. Madam will share. Okay, so anyway, you take the photograph. These are the 11 courses which are there, mostly physics and electronics and computer science together. A lot of mathematics is involved in all the courses. So people who are from physics, maths, electronics and computer science, definitely you can take this course. We finished the first three courses, programming, quantum foundations and quantum technology. These videos are available. You can directly do the course. We will start a cycle. Many are requesting me, maybe we will start the second cycle, right? But then if you start the cycle, then you have to follow the cycle only. Okay, you can't club this one and that one, so you have to follow the sequence, right? So 5, 6, 7, 8 is what we are going to do till December, right? QT04 we will do in the last week of December maybe. That's the schedule as of now. The 9, 10 will start in January, February. Meanwhile, we will start the second cycle. Let's hope we will start it sometime, and how we are able to do it, we will see, right? So this is one thing that I want. Now, I wanted to start with 3 questions. What is the basics of thing that you understood? So this is one video you should listen to, right? These are basically what are called basic principles of quantum, right? So one thing is very clear, 4 concepts I want to check whether you understood, because you are the last day of the course. Then we will go into quantum hardware, right? The first question is, if you understand what is superposition, in your own words, tell me what is superposition. Multiple phases. చెప్పండి సార్. No, I am asking one question only. Don't go to entanglement. Tell superposition. Multiple states at one time. One on another means? Is it fuzzy logic between 0 and 1?
Yes. Qubits can be added simultaneously, sir.
Okay. Okay. Now you differentiate between qubit and classical bit, right? Classical bit 0 and 1, binary digit. Binary digit means either 0 or 1, right? Qubit is quantum bit, right? How is quantum bit different?
So it takes multiple states.
It takes multiple states. In the morning, before concluding, we talk about deterministic finite automata, non-deterministic finite automata. Deterministic finite automata can see 0, go to one state, see 1, go to one state. But here, on seeing 0, in quantum, it can go to multiple states. And it can go to multiple states. So, there only it is like a switch, either 0 or 1. Here, it is like a 3-dimensional globe. Okay? So, between 0 and 1, 0 is north pole, 1 is south pole, let us say. So then any values in 3-dimensional between 0 and 1, that is a qubit. Number of qubits will decide number of states, right? If you have n qubits, 2 power n states, that is superposition, right? I can be at multiple states at the same time, right? What is the strength that we are giving? That's why I was asking the question correlated to hardware, right? That was why I was asking what is the speed of the processor. How do you differentiate the speed of the processor? Then they said, sir said, vibrations, oscillations, right? So, the oscillations of what was my question? No, we are talking about classical. Qubits lo kelladu inka. We are talking about CPU. CPU speed is 1.8 gigahertz or 2.5 gigahertz.
Both the sides.
But what is the frequency? Frequency means oscillations. Number of times 0 and 1 you can do. On what basis is it decided? No, not quantum. Classical. Of the transistor, right? But oscillation of what? Of what? What atom? Semiconductor. This is what I was looking at. What is semiconductor in a chip? Some material, silicon material, right? So chip basically is consisting of silicon material, where you are doing very large scale integration VLSI and putting more chips or more transistors or more these are helping us to create our gates, and each gate is able to help us in some operations, right? So based on the oscillations of the hardware of that material, that is the semiconductor material, whatever material it is used, that material's oscillations will help us in the number of operations that can be performed by that chip. Okay, and that is why we say floating point operations, because floating point operations take more time. The measurement of a chip, because that is minute, the other integer operations are minute compared to floating point operations. So they say floating point operation, whether it is petaflops or teraflops or something like that, it gives on, right? So that gives the power of this thing. Now correlate that to quantum. Now you come to quantum. Now you think quantum.
So one basic question.
Yeah, please.
I want to get clarity. 0 and 1, 2 states, that's very clear. Whereas in this case, multiple states in the same time, I am unable to get. Many of the examples, this coin they are showing, one side is 0, then another side. Both sides, heads will be there.
Both sides, one is head and one is tail always.
Always.
But when we look at while the computation is going on, right, that is the power that it gives. It is either 0 or 1. We don't know, because it is revolving very fast. We don't know whether it is 0 or 1. Finally, when it comes to my hand, it becomes, that is where I do measurement, and finally I get 0 or 1. So this computational process,
Yeah, during that period, we used to catch them.
that is non-determinism. That is what we are using to do something, but finally it will result in the measurement. At that time, we will get the final value. Right? So the power of quantum is coming from those number of states. Now coming back to understand how those number of states are coming for me. How am I getting those number of states? Now you go back, because it's your subject, right? Now you know quantum mechanics comes there. That is where quantum mechanics will come. Quantum mechanics will allow the electron to move to a higher state, and it is moving in multiple things. Right. At that time, you can, and they are used for measurement. So when you write the code and pass it to that, and when at that temperature and at that electrons are moving, we are able to do more operations per second. Now how that is done will take a lot of time for you also to understand, for me also to understand. I am also trying, but I correlated what is happening in CPU, what is happening in a quantum processor. We have not, nobody has opened or told you anything about this is a processor. Now what I did, I told you the processor names. Now what you can do, you can go and study the architecture of the processor from a quantum perspective, right? What they did, how they are doing, there are multiple steps of doing it. The cost is not very high, but who will give us that cost is the question, right? Now sometimes we have to spend, sometimes government will give, but now what we are doing is, let us be aware of those things, right? Now my dream is someday we must come up with a quantum processor of our own. Okay, let us start now. Maybe you are 30-40 people, okay, 10 of you form a group, multiple colleges, you work together. Let us not worry who will get the name, right? Whoever is working more hard will get the name, but let us all join, right? And then try to get somewhere, right? Whoever does more work, let us give him the credit, and finally if a team gets this thing, we will win. First let us make India win, right? So for that, let us all work hard. That is my this thing, right? First thing you understood. Second thing we are talking about, yeah.
Sir, during this course, faculty saying that represented in the qubits is accepted state or down state, and few videos they saying that they represent the spin precision, spin up or spin down. Which one we should take? It's a spin or
There are multiple approaches. Like in the processors, when I showed you, there also I discussed. Some are topological qubits, some are using semiconductor qubits, right? So everything will have a different approach, right? So most of the processors have one approach. I think Ocelot, that is AWS, having a different approach. That also comparison we'll discuss. Quickly I will take you. If you don't understand, don't feel bad, no problem. This is first time when I took in one of the college, no questions asked. I said, you are still in shock? Many said, yes, the thumbs up. Because first time it's not new. What I am telling is something related to your subject. If you are physics and electronics, you will immediately correlate, right? Then okay, this is what I should do. Now that is we have not done. What CDAC is telling now is, we have a single qubit quantum kit. You can start there. You can buy that kit, right? For that lab also, you can propose, right? I will give you the link. Maybe I will pass to madam. Okay, when you set up, there is a call for National Quantum Mission. July 23rd is last date. Quantum algorithms is July 31st. That is project. Setting up quantum lab, I think, okay, they have restricted some colleges only, I think. Okay, so don't worry. They have said NIRF 100 colleges or something they said. Now what you can do is you prepare. Because National Quantum Mission, what it will do is, what is the second project when it comes, second call for projects, those who want to start in 2026, they will say you set up the lab, call will come January, February.
Sir, quantum computers cost and components.
Quantum computer cost few $1,000 లోకి వెళ్ళిపోతుంది, చాలా కష్టం. 1 qubit it may be something around 60 lakhs. It's a kit. ఇంకా 60 lakhs. QPI వాళ్ళు they are giving the basic 8 qubit quantum processor they are giving for 8 crores. That is the cost. 8 qubit. 25 qubit they gave 25 crores. So they are selling 8 qubit for 8 crores. So I mean this is what I am telling. These are I mean don't quote to QPI AI. That is the rate they gave me. If you want to buy and set up in Rajasthan, we will give you for 8 crores, 8 bit. 25 qubit means like something like 25 crores, right? They will set up the everything and you will have to maintain it after that.
They have the mechanism to construct the
8 qubit is there. CDAC, they have CDAC Pune, they have set up 1 qubit, 60-70 lakhs, something like that, right? For a demonstration purpose, you can start. So you can buy that, right? And within 1 year time from now, you can create that in your own lab. It will not cost 60 lakhs. Because they want to make some money, they are selling for 60 lakhs. But if you may send some 20 lakhs, I think, because the equipment itself is the thing. So you can try. But you can start, right? Then few of you can come together. If the college is very satisfied with whatever you are showing them, they will. Government will also fund. Not only institute, government will fund. But you will have to do something. You start somewhere, right? That's what. Now, second question is on entanglement. If you have understood entanglement correctly, what does it mean?
Connectivity between the stages. Connectivity
changes to effect to another.
Right. So 2 qubits which are anywhere. What is the distance? How far can be the distance?
Distance, there is no matter.
Theoretically they say is infinite. Any distance. So you can talk to, if somebody of you are working in
within the boundaries of the process.
right. So if you look at practical implementation, it will be some distance, but theoretically it says infinite. Matlab you can think of creating a quantum. If you really have a quantum processor, then that quantum distance can be covered. So you can actually talk to that Chandrayaan failed and all. At that time, quantum communication failed. Communication failed. If quantum communication was realizable at that time, we could have repaired that thing and got it back. Okay, we could not get it back because the communication failed. The channel failed, something on the device failed there, right? So because of, I think it fell down or something and broke the antenna or something, so we are not able to contact. If we could contact it, we could rectify the software. We had that capability. Only thing is that communication was not possible. Now the communication is possible, so we can try to look at. So this is something that we are trying to look at, right? So entanglement is one will influence the other, right? One, if there are 2 qubits, then if there are 3 qubits, they will influence. Like that, as the number of qubits are increasing, so you can have that much of power. So that is the second. Now coming to third aspect is of course measurement, but before that is interference. What is interference? When 2 qubits are there, both will have a different mechanism. We can combine them, right? When we combine them, they can add up or they can cancel out, right? So you would have understood that what is that? Inner product. The word that is used is coherence and decoherence. Differential addition and differential subtraction, that is there, right? So basically you can follow this video very simply. Let's look at it for once.
Classical computer are called bits. The building blocks of a quantum computer are called quantum bits, or qubits for short. They work in fundamentally different ways. A classical bit is kind of like a switch that can either be a 0 or a 1, which you're probably already familiar with as binary or binary information. When we measure a bit, we just get back the state that it's currently in. But we'll see this isn't true with qubits. The qubit is more complicated. For a useful visualization, you can think of them as an arrow pointing in 3D space. If they point up, they're in the 0 state, and if they point down, they're in the 1 state, just like the classical bit. But they also have the option of being a thing called a superposition state, which is when the arrow points in any other direction. This superposition state is a combination state of 0 and 1. Now, when you measure a qubit, the output it gives will still end up being either a 0 or a 1. But which one you get depends on the probability, which is set by the direction of the arrow. If the arrow is pointing more upwards, you're more likely to get back a 0 than a 1. And if it's pointing downwards, you're more likely to get a 1 than a 0. And if it's exactly on the equator, you'll get either state with a 50% probability. So that's the effect of superposition explained. Now we'll move on to entanglement. In a classical computer, the bits are independent from each other. The state of one bit is not influenced by the state of any of the other bits. But in quantum computers, the qubits can be entangled with each other, which means they become part of one large quantum state together. For an example, let's look at two qubits which are each in different superposition states, but aren't entangled yet. You can see the probabilities next to them. These probabilities are currently independent of each other. But when we entangle them, we have to throw away those independent probabilities and calculate a probability distribution of all the possible states we can get out. Either 0, 0, 0, 1, 1, 0, or 1, 1. The important point here is because the qubits are entangled, if you change the direction of the arrow on one qubit, it changes the probability distribution for the whole system. So the qubits are no longer independent of each other. They are all part of the same large state. And this is true no matter how many qubits you have. You'll also note that for one qubit, you've got a probability distribution over 2 states. For 2 qubits, you've got a probability distribution over 4 states. For 3 qubits, you've got a distribution over 8 states. And this keeps on doubling each time you add another qubit. In general, a quantum computer, n qubits can be in a combination of 2 to the power of n states. So I'd say that this is the core difference between classical computers and quantum computers. Classical computers can be in any state you want, but can only be in one state at a time. Whereas quantum computers can be in a superposition of all of those states at the same time.
But you may wonder how being in the superposition state would be used for a computer, but for that we need the final component, interference.
To explain the effect of interference, we need to go back and look at my picture of a qubit, technically called Bloch sphere. Now, a qubit doesn't actually look like this. This is just a really nice way of visualizing the state of a qubit. In reality, the state of a qubit is described by a more abstract entity known as a quantum wave function. Wave functions are the fundamental mathematical description of everything in quantum mechanics, which I've described in more detail in a previous video. When you've got many qubits entangled together, all of their wave functions are added together into an overall wave function, describing the state of the quantum computer. This adding together of wave functions is the interference, because just like we say with ripples of water, when we add waves together, they can constructively interfere and add together to make a bigger wave, or destructively interfere to cancel each other out. The overall wave function of the quantum computer is what sets the different probabilities of the different states. And by changing the states of different qubits, we can change the probabilities that different states will come out when we measure the quantum computer. Remember that even though the quantum computer can be in a superposition of millions of states at the same time, when we measure it, we only get a single state out. So when you're using a quantum computer to solve the computation problem, you need to use constructive interference to increase the probability of the correct answer, and use destructive interference to decrease the probabilities of the incorrect answers, so that when you measure it, the correct answer will come out.
And how you do this is in and around the quantum algorithm. And the motivation behind the quantum computers is that theoretic.
Yeah. So So these three concepts are important. So now I hope this, so please go through this complete video which is called the map of quantum computing, right? So I think somewhere at the end it will come, I think map of quantum computing. You can so there are so many concepts which are explained in this video, and in fact domain of science, this is the right. So map of computing poster, you are not able to see that, right? This one. So domain of science, DOS is the website, so you can follow that, domain of science. So all the concept of this whole concept of this entire thing is taught, right? All the concepts are taught. So you can, it's about a 1 hour video, you can view that. So I wanted you to understand these three concepts, then you will be able to understand what I am talking about, right? So that's why I wanted to revise that and move beyond, and let us go back. So these are the videos that I told you, this is the syllabus. Now let's go to our lecture. So the 4 processors that we talked about, we had Indian processors we have. So you can access these links, this will be there, I think he has placed the links here, right? So these are links, you can click on that, it will go to YouTube link, right? So this playlist link is also given, the madam will share the slides, you can view this. So these 3 courses content is there, right? So when we talk about, I'll quickly do this because it's prerequisites, what are the concepts that we have, you have studied. If you have, they may have been taught in this part of the course, or some part could not be covered. So please read quantum mechanics, electromagnetism, electronics, mathematics, which is basically linear algebra, complex numbers, and also differential equations and partial differential equations. A little bit of programming, especially Python will be better. So these are some kind of prerequisites you can think. I learned Python. I was not taught Python, but I taught first year Python, students for first years in Python. I literally sat, wrote the programs last 2 years ago. The first time it was introduced, nobody was wanting to take Python. So I said, okay, I will take. Now those slides are being used. Okay, if some of you are interested, you ask me, I will give you Python slides, right? So you can read through. A lot of material is available. Geek for Geeks, Program Biz and all. So many websites like youngsters may be using for their placement. They give lot of content and lot of slides. They explain everything very clearly. So for learning, there is no dearth of information. So this is the kind. So understanding these 3 words is what is very important. Little bit, if you want to go a little deep inside, you will understand Schrodinger's equation, Heisenberg uncertainty principle. These are words that you know. So and spin measurement. So roughly around 3 months, lot of content is available. You may have to spend part time if you do it. It's 3 months. A little bit of electronics is required. RF circuits, LC circuits, Maxwell equations, very important. And of course postulates also are there, so you can look at that. Little bit of understanding oscilloscope signal generators will help. Optics, physics optics will help, because single slit experiment, double slit experiments and all those things will help us. So this will help you to understand the things, roughly 1 to 2 months of that. Mathematics, complex number, probability is used because the 2 states are based on probability amplitude, so you can do that. Eigenvalues, matrices, Dirac notation must have been taught, so 4 to 6 weeks. Python programming, Qiskit and Circ, and of course QSIM, Penny Lane, all these you can try. A lot of books are there, you can view at them and look at that. Hardware interfacing, some of you who are wanting to look at the lecture that I am discussing, so try to get hands on with Arduino, Raspberry Pi, right, and interfacing. FPGAs, microcontrollers, all these concepts if you study, you will be able to confidently explain. That's what I am telling. Not all are required for the course. If you are taking a physics related course in the quantum syllabus, everything you need not, right? But if you are looking at writing a project for quantum, so some of these questions will come, right? So reading all these will be a good advantage. About 1 month you can. So about 6 months part-time study minimum is required, right? So if you are starting now, don't get disappointed. Everybody is doing, nobody is doing anything, right? And all those who are writing projects, nobody has a paper except for few IIT, PhD physics who are doing. They have some papers on quantum physics, right? Quantum computation, very rare. Indians who have written papers, who are in India. One book came with 3 authors. Indians. Immediately I purchased the book. Right? I opened the book. Which institute, which university? All are working abroad. 3 Indians who are working abroad in various universities and companies, they came together and wrote a book. And I purchased. I was thinking it will be slightly Indian oriented, Deshi type language. It's all are foreigners. Now they are all non-resident Indians. So now the challenge is there. Ashwath Babu is writing the book for AICTE on QT05. When Ashwath Babu sir can write, some of us, 2-3 people of you can write. Right? Don't copy paste, but you work it. Once you work it, you can write. That's what I am speaking. Right? So like that. So this is something which you can do. If you have physics and maths, if you are strong, electronics people are usually strong. So and physics and maths, if you have, obviously you can accelerate it. You can do some small. So now we will start what is the survey on quantum qubit platform options, right? So now actual talk started, and some of the things are relevant to you because you must have done in your own subjects, but then how to use it is the question, and how to do it is the question. So supercomputing qubits are fabricated circuits using Josephson junctions, right? So Josephson junctions, anybody used? Superconducting, right? So Josephson junctions are basically used in most of the quantum processors, right? So you get very close to it, one thing, and after that what you can try to do is you can see how the existing chips are being manufactured using these Josephson junctions, right? So this is one of the example of a typical supercomputing chip. This is how the internal architecture looks like, right? So they will operate at millikelvin temperatures using dilution refrigerators. Some of the physics departments may have these dilution refrigerators. They are also costly. I don't know whether university has. No, it's very costly. So dilution refrigerators are one thing which is the challenging. So when I talked about cryogenic, to maintain the temperature is the challenge. So but then we can start thinking how we can do, or whether there is some other facility where we can test our creation, right? We can do that. That is one aspect. So basically the dilution refrigerator is the one that is there. So supercomputing qubits are the best or the most mature platform, or this is the domain which everybody is using, right? So that is something that you can look at. So there are advantages and there are disadvantages, because many people are working in the same domain, nothing much is there because they are already achieved lot of things, right? In other domains there are openings. You may come up with a better chip using those mechanisms. That's the question. Now tens of thousands of nanoseconds is what is the gate speed that they are achieving. IBM Condor in 2024 tried to look at 1121 qubits. They demonstrated, right? So 1121 Condor, right? So this is some of the thing that could be achieved, and there is lot of fabrication and software support. In India I am not sure, but definitely you can get it done, right? But the problem is this complex dilution refrigeration. It is very sensitive to noise. This is the disadvantage of supercomputing conducting qubits. That is, coherent times are tens of microseconds. So it will be kind of sensitive, right? So you can't, you will have lot of these things. Then wiring complexity for large qubit counts. If you want to increase the number of qubits, the wiring complexity, the wires you have seen, thin wires, so that will become the issue here. And of course the cost is also high, right? So this is something that you can look at. The second model is a trapped ion qubits, right? Anybody heard trapped ion qubits? Theoretically you would have taught. What are trapped ion qubits? No?
We try to use the atoms. We
Huh.
try to trap the electrons by using the laser lasers.
Correct. So that is the basic thing. So these are actually in I think Masters of Physics and MTech Electronics, I think the labs, these are being available, right? So physics labs and electronics, if they come together, we can do that. As far as the hardware is concerned, computer science people usually they will do at the Qiskit simulation level. Most of the thought process is at that level only. We usually, myself included, we are not doing much of these things. So this is something that we can look at, right? So the qubits are encoded in internal states of ions confined to electromagnetic traps, and as sir just mentioned that we try to use lasers and we try to trap the ions, and then we can get that. So as you see, there is an ionized laser here, and the atom beam is going. There are metallic mirrors inside. So what you use is spectroscopy loci, and then it's a laser cooled trapped ion chain. So this is another way of doing it. So here the advantage is the coherence times are better, seconds to minutes, and very high gate fidelities. Previous also high gates, here also you can create high gates. So uniform qubit quality and all-to-all connectivity is also the advantage. And here room temperature trap apparatus you can do, some of them are doing. So you can also try to build it, right, and this mechanism is easy. So but the gate speeds are slightly slower, microseconds to milliseconds range, not nanoseconds range, 10 power minus, this may be 10 power minus 6 and minus 3. So that is the kind of 10 power 3 is the kind of thing that we look at. Complex multi-wavelength laser systems are also needed to trap the ions, so that is the another thing. And then you have scalability is limited by laser beam addressing. Again, laser beam generation and all will be costly, so that is the other aspect. Of course, a little bit of maintenance of that vacuum, that entire thing should be in vacuum, so you have to maintain that. So that high voltage engineering is also required to pass the what do you call the laser, so that is where these are the pros and cons. Photonic qubits, this is the third model, right. So photonic qubits, they use single photon, so polarization, path or phase, and basically they are optical circuits. That's where I am talking about optics. Quantum optics is very important for quantum computing. So one of the course has a lot of content on quantum optics. If you understand, then you can do that. So it's a basic photonic quantum circuit. My friend also is able to do on in MNIT Jaipur using materials. So a person is in physics, but he is working on materials. We have a material research center there, and because of that advantage, he is able to one of the PhDs awarded based on these photonic qubits, right. So he tried to implement that, and this also can be handled at the room temperature. So we can try to do these things. So the probes are placed here, and you have the okay, and so you have this 3 to 5 semiconductor single photon source, you can place it here, and of course the top cladding, and you have an etched pit. Then you can try to create using this thing. There's a waveguide loss, and you can create this thing, and the fiber which is collecting from here. So this is a basic circuit which is done, and the advantage is you can manage it at an ambient temperature. It's low coherence, low environmental interaction. You can use it for quantum communication, and low cost demos of off-the-shelf optics. So you can easily show it to students that this is how the things can be created. Requires an on-demand single photon source detectors. This is the one which is able to detect the photonic, I think this one, this collection fiber is what is the exact thing that is required. So that is the one, and then loss and detection inefficiency, scale with circuit size, so it's not very high. 2 qubit gates increase the resource overhead, so single gates are easy to construct and demonstrate. High redundancy is required for error correction. So in this case, the error correction will be more. So that is that means the errors will be more. So error correction will be needed. So if you want to give better error correction, you increase the redundancy, that more devices will be there, right. The third one is spin qubits, right, as we looked at, right. So these are different approaches. I am just skimming you through, then we will compare the technologies also, right. So use of a electron nuclear spin in quantum dots, donor atoms, or diamond nitrogen valency centers. So anybody used the nitrogen valency centers? NVC, nitrogen valency, nobody? Quantum sensing it comes, yes, but you need a VNC.
Very large scale.
No ma'am. This is the NV centers which we call nitrogen valency centers which are there. I did not add that, I think we should have added, right? Let me check. Okay, you browse what are nitrogen valency centers, right? So and then you can check up NVC. NVC is what is called. You can check up NVC and you will get that, right? So what is happening here is basically optics, right, which is being used here. So there are some probes, and you have a diplexer here. So here you are trying to measure that. So there are some lens which are used, the single slit experiment and all that kind of thing we are doing here, pinhole, and you are passing. So the fluorescent under laser excitation is shown like this. So this is how the spin qubits are used. and the advantage is basically you can do it at CMOS compatible fabrication. So electronics people, you are understanding what I am talking about. So CMOS fabrication, silicon quantum dots can be created. Long coherence in isotopically purified materials. When you have good material, you can have long coherence. The nitrogen valency centers operate at room temperature with optical readout, right? So you can try to look at that aspect. Some variants will require cryogenics. Again, the temperature requirement to be maintained, so cryogenics are required. Precise control wiring at scale is challenging. When you want to increase the scale, precise wiring will be a problem. The nitrogen valency multi-qubit coupling is extremely difficult. This is another limitation. And also high error rates without ultra clean environment. So this equipment we need to keep at ultra clean environment, which is which will be totally bound and maintained in glass, and no dust. We should not allow any dust, and temperature should also be maintained. Then you have neutral atom qubits, right? So each of these is one domain, right, of hardware related, and this is very close to what our physics electronics is being taught in colleges at various streams. Now only thing is we need to start from where we are and try to move to this level. That is what we are to do. So here we have neutral atoms, rubidium, trapped in optical tweezers or lattices with Rydberg excitation enabling qubit interaction. So there is optical tweezer array for cold atoms. So you can see that scalable arrays of hundreds to 1000 atoms you can create. Long coherence at room temperature apparatus, flexible connectivity via atom transport, but require complex laser cooling. Precision optics and alignment challenges will be there. Slower gate speeds, requires full AMO lab infrastructure, so that air and dust free environment is what is required. So this will be for neutral atom qubits, right? So let us try to compare these platforms, coherence versus gate speed versus infrastructure. Coherence means how best the coherence will work, interference will be handled, or errors will be controlled. Gate speed, how far, how many gates or how many qubits I can manage, increase the gate speed. And the infrastructure, the hardware creation, setting up, and the maintenance of the temperature, what is there. So we will look at also some do it yourself friendly entry, that is photonic circuits and nitrogen valency centers, we can do that. So lab scale, for scale superconducting neutral atoms, this is easy if you want to do it at the lab scale. Choose based on goals, budget, and available expertise, right? So there are some articles which you can look at inside HPC, these are blogs, okay, and then Spin Quanta, these are websites which are there, so you can look at that. I will share the slides. So mostly I think he would have put the links also. No, I think not a link, right? But then you can just type that. GK Gadgets photonic demo examples are there. Quantumcomputing.sc, there is a discussion forum on photonic gates. You can look all these things, whatever is interesting to you, go there, read the material and see if we can do some of these experiments in the lab. Then offer it to students and excite them on quantum computation slowly, right? So these are some things which are doable, and your college may give you the budget, few thousands of rupees, right? So if you say $1,000, how much is it? 80,000. College will give. If you say, sir, I want to set up one quantum experiment and cost is around 1,15,000, college will give one experiment cost, right? So if you say 8 crores and all, they will not. 40 lakhs also they may think, but 80,000, 90,000, these are all $1,000 projects, which you $1,000 is 80,000, $80,000 projects, 80,000 rupees projects, right? Now when you look at the comparison, these are all the things that we discussed, okay, and it's a representative qubit hardware setup. This whole room is maintained in the temperature, that's what we are looking at, but these 5 options are what we can try to look at, and I am trying to compare all 5 of them, right? So here is roughly it costs about 100,000. This will be the costliest one, because we are talking about superconducting. Superconducting is costly because the temperature has to be maintained, right? And hence that maintaining of the temperature, the cryogenics part itself will be very costly, right? So, but you can generate up to in 2025 50 to 100 qubits in operation and 1121 qubit by IBM. It is not do it yourself feasible, right? it's a big project. If somebody gives a big project funding, you can do it, otherwise it's not possible. So because of the dilution fridge, that is you have to maintain it millikelvin. So $100,000 is for the fridge alone, right? Then the equipment will be even more costly. That's where that 8 crores, 7 crores will come. So that is the thing. Trapped ion is challenging but possible. So requires that vacuum that we discussed to maintain the trap. So this is $10,000, right? Roughly you can tie, but this is costly, but you can attempt up to 50 qubits, right? So IonQ is another company which does about 36 qubit it has done. So they use trapped ion qubit platform. So when you look at the photonic, it is highly feasible at small scale. Most of you may be working with photonics, so those who are in electronics and physics, you can try to look at that. So simple optics for 1 qubit, few $100, okay, definitely less than 80,000, right? 50,000 to 80,000 you have to spend. So that is something which we should target, and we should set it in a lab experiment and offer a quantum course, or in your physics course itself offer it as one extra experiment to motivate students to start thinking about this. Even in electronics we can do that. So presently that call is getting over on July 23rd, but let's target next year. Some of your colleges, let's target it next year, right? And please conduct some workshops at your own, right? You can call some of the faculty who have come here, or some of them who attended these training courses, you can invite them, because everybody has the content now, right? Only thing is they also have to learn it, read it. If they are from physics background, they will be able to explain the fundamentals. If they are from computer science background, they will be able to explain the programming part, right? Qiskit and Penny part you can explain. So and then if you are able to take something and show it to students and faculty also, that will be the greatest thing. Nobody is able to do this. Most of the people who are coming to deliver lectures, they are coming to talk only about software simulation, right? Nobody is talking about any hardware. But if in our lab, if you are able to set up something and show students, they will be excited. I was very much excited with Newton rings in the first year when it moved like this, and even the laser also when the colors came back, you know, that was, so we are not doing that. That excitation has not come. Now if we do these, the excitation will come. The college will also be very happy. If you say in 1 lakh, sir, I am going to demonstrate quantum to students, right? But now you have got information, and after this you don't have to ask me again, right? Now Google Baba will tell, and or otherwise our latest innovation is there, na? ChatGPT will tell, right? So some of the content will also be available in ChatGPT, right? My student prepared all these slides, so he has also looked at some of these things, so you can look at that, right? Again, as we look at this part is very much available, $5,000. So 1 to 2 qubits in academic nitrogen valency experiments you can do, 3 to 12 qubits in research labs you can do. So single qubit and 2 qubit experiments definitely we can target. So that is something that we can try to look at. Neutral atom is not, again, not do it yourself feasible, requires full cold atom lab. As we saw in neutral atom, we said that temperature of that cold atom lab has to be maintained, which is not possible. So 1000 plus atoms in arrays reported by atom computing. So they are these experiments which are coming. So basically trapped ions, NV center spins and photon qubits are the most viable for beginners. They balance a quantum operation with manageable lab requirements, and nitrogen valency centers enable room temperature single qubit experiments with simpler experiments. So these are basically the optics part is what is offered by CDAC. So I will share that details also. I had a call discussion with madam in CDAC Pune. So once she tells, I will share that with you so that you can try to set up in your own institution when you are ready for that, right? So photonic excels for demonstrating principles through general computing scales remaining challenging. So the scale may not be achieved, number of qubits may not be achieved, but 1 or 2 qubits, the easiest version will be photonics, right? So there are some do it yourself quantum experiments which you can do, and we will look at the trapped ion route, noting differences for other platforms. So if you look at what is the bill of materials means what is the equipment to be purchased, or if you want to set up a lab, what are the requirements. So that is what we are discussing. So when you look at general supplies, we look at, then if you are looking at supercomputing qubit, so these are the options: supercomputing qubit, trapped ion qubit, photonic qubit, spin qubit, that is the nitrogen valency center, neutral atom setup. So 6 options, right? 1, 2, 3, 4, 5 options we are discussing. So you can try to look at these when we look at, right. So, we are compiling the hardware components required for each qubit platform. We are looking at the estimate costs. Maybe you need to look at who are the suppliers. Few companies are able to come up and they are saying we will provide these quantum equipment, right. So, most of the things they will buy, integrate and bring it to you, and you can try to look at, right. So, a vibration isolated optical table or stable surface is required. So, the bench that we look at, so that is what is required, and electronic rack where you multimeter, oscilloscope and vacuum gauges are required. Standard lab tools like laser goggles and gloves, which are basically used for optical experiments you need. So, most of the systems will have. So, a few thousand US. If these are not available, the common supplies will be the bench, and these equipment will be few thousand US. So, few thousand means 3000 meter, let us say 3 into 80, right, some 2.4 lakhs. 2.4 lakhs is not a problem for any college, right. So, you can try to look at and set up the bench and all the equipment you can buy, right. So, if you are looking at a qubit chip, so you can custom fabricated on a transmon on silicon. So, educational kits are readily available, like I was mentioning CDAC, QPI AI has some readily available, and few companies also which are working on quantum, they also have this, right. I will share some of the details. The challenge will be for doing the supercomputing setup, obviously not the superconducting setup. The major challenge is the dilution refrigerator, which is the cryostat. So, that is the problem. So, hence of course, you can look at when you want to do it at a later stage. Cryogenic wiring and RF is required, where you need to have a low temperature coaxial cables, attenuators, isolators and these things. So, 10,000 plus dollars for a single qubit line, right. So, room temperature electronics, so microwave generators and all those things are available. So, infrastructure, helium plumbing, vacuum tubes, ODN monitor. So, roughly 150,000 US. So, that is why it is the costliest equipment as far as information that is available, right. Dollars 1,50,000. So, that is huge amount of money, right, goes into some crores, right. But this is what is readily available with most companies to sell. Most of them are using the Josephson junction, which is basically helping in superconducting setup, right. The trapped ion, basically you need the vacuum chamber and the ion trap, which is costliest. So, this is the range $500 plus. So, gauges are less, but you need multiple gauges. So, you have a 6 table cube with view ports, you can buy this. You can set up an ion trap, $100 each. So, this will be mostly realizable cost that you can look at, and if you have different parts, you can have $5,000 you can start, right. So, something like 4-5 lakhs will be the cost that will be involved. Ion source and laser machine will be about $300, and you have the 399 nanometer ionization laser, that will be the cost. Cooling, laser cooling will require something like $10,000 to $20,000 everything is, and optics, okay, this was the ion source and laser systems, right. This is the third option. Fourth option is optics detection and control electronics. So, mirrors, lenses, mounts, $50 to $300 each. So, you will have few numbers, so according to the cost. Objective lens will be about $1,000. Detection, both these things in the scientific camera roughly 3 to 4,000 US. RF electronics, that is 200 megahertz generator, RF amplifier and then LC resonator, which you can create yourself. DIY means do it yourself, right. So, these costs you can do, roughly this will be about $30,000 for a single ion system, right. So, you need a microcontroller based control system. The photonic setup, diode lasers roughly $200 to $100, and optical components, polarizers, beam splitters, wave plates, detectors, photodiode, single photon detectors, roughly $1,000 for a polarization based qubit kit. So, this can be again realizable within $1,000. So, you can do that. Optic detectors, photonic setup can be done. Most of the quantum related companies are doing, they are assembling all these things and giving. right? So I will give you one or two links. You can look up their companies and then look up. So diamond with nitrogen valencies, so something like 500 to 1000 for a lab grown diamond. So excitation laser $1,000 to $2,000. Microwave source, anyway, this is most of the things will be available. So what are not available, you need to buy and then try to set up, or if you want to set up a full quantum lab new, buy all of them as a separate thing and try to do it. But we all have to come together, okay? Physics, electronics, computer science and maths have to come together and work on these. So then you will have to roughly $5,000 you can get a nitrogen valency center. This will again be costly, neutral atom, so because of the temperature that has to be maintained. So you have the vacuum mott and optical tweezers and Rydberg laser also you can have. It is beyond do it yourself scope because it's about $300,000, which is not possible. So this is the overall comparison as we looked at. So the cost, that is the optics lab, can be possible $2,000. This can also be possible $1,000, and this one, right? Atomic this can be done. So these are options which are there. Of course, these are all outside the people. We don't have anything which is made in India. So few companies are getting from them, assembling and giving to it as a kit. Kit is readily available, so you can look at that, right? So you can have a detailed BOM and then order the subsystem. You can do that, right? So there is an assembly guide also which is created. So you have to first do the physical setup, achieve the operating conditions, install and align the hardware components, then first qubit capture, then the cubing state control, and you can scale up. So you can look at that. So I will share the slides. You can look at this part. How do you do that, and each of these. So how long it will take is also mentioned. So these are various things that you can do and try to set up something like this. This is an example of a vacuum chamber assembly, vacuum cooling and all that. So these are, I think we'll skip this part. You can do this integration. So this whole thing, after this whole thing is set up, then you will be able to do the observe the qubits and entanglement. So these are something like 1 year is what it will take for us to set up, right? So roughly about 1 year you can do that. You can also try to do it fast, but this is usually the timeline that we tend to look at. And of course there are some control software and firmware which you can do. So basically there are 5 modes of operation. Now trying to understand them and trying to create one mechanism is what we need to be there. Here also I think there is a comparison which was done. These are the software systems that we use. Somewhere we had a comparison with the types of use. Yeah, okay. So this is what I wanted to bring to you, that we have to move in this direction is what I am trying to look at, right? So at least try to create a single qubit setup and make it available to students. First we will see, like when I saw the quantum processor, the QPU setup in QPI AI, right? Okay, I felt okay, this is what they could do. So when we discussed if the institute can afford 8 crores, we will have. So they said they are doing it with Karnataka government and also Telangana government, because IBM has already done for AP government. So they will set up for them, okay, but it will be done at a state level because few crores are involved. But the access can be given, like how IBM is giving access of 10 minutes, like the IBM Heron 2 which will be set up, it will take about 6 months to 8 months because this whole time has to go in, right? They have to place the order. After placing the order, all these equipment will come, they will assemble and they will set up, and then that access may be given. So AP government universities will get access to IBM R2, right? But what is the problem if access is there?
Everybody can go on.
But who can go? We should understand what to do. I may be given access. What I will do with that access if access is ready? So my challenge to you is, one thing is understand this and do something for your student. Second thing, be ready when that access is made available to you, that you have a problem. So then the AP government will say, okay, what problems are there? Please apply to us, we will give you quantum time, right? In when IISc set up the cluster for GPU, a big GPU cluster they set up, and they said, okay, you take the access, National Supercomputing Mission, NSM it was, now is NQM. NSM gave that access, so we applied for a project, we wrote 20 lakhs project. They said you don't have to buy any GPUs. Why? Because we will give you full access to GPUs. So they gave us GPU access, we loaded our data and ran our programs, and we got the results. 2 transaction papers my student has secured in that IEEE transactions, right, because of that access, right. We will not be able to achieve that access, it will take a lot of time. Similarly, quantum access will take a lot of time, but if you have a problem and when access is given and you apply and if you get the results on live hardware and you can submit, you can get very good publications. This is the starting, right. So now I try to bridge the gap between quantum hardware and quantum software. Simulation thought process is over. Now reality is coming in. Till now we are saying it's going on in air. గాల్లో మాట్లాడుతున్నారు, అయిపోయింది టైం. ఇప్పుడు ఫిజికల్ ప్రాసెసర్స్, ఫిజికల్ ఎక్విప్మెంట్ మనకు కనిపిస్తుంది, ఇవన్నీ మనం చదివాం చేసాం. సో ఇట్లాంటిది మనం సెటప్ చేయగలుగుతాం. సింగిల్ క్యూబిట్ వెరీ ఈజీలీ యూ కెన్ సెటప్ విత్ యూజింగ్ ఆప్టిక్స్ ఫోటానిక్స్ను ఆప్టిక్స్ వాడి ఈజీగా సెటప్ చేయగలుగుతారు. ఎలక్ట్రానిక్స్ ల్యాబ్, ఫిజిక్స్ ల్యాబ్ కంబైన్ చేస్తే అయిపోతుంది. నౌ one thing that most of you are looking at the lab kada, so that what they need in the lab is what I was looking at. So they had this is call for proposals for UG teaching labs, but they have restricted it for some type of colleges. This is the template. This is the equipment. This is what they have suggested to buy, right? Some of these things are available in physics and electronics lab, right? So I discussed in our things, like I was talking about VNA, RF VNA is available. So polarization optics, optics interferometry, diffraction, single slit and grating, Michelson interferometer kit, quantum cryptography analogy demonstrate crit. This is available with CDAC, quantum distribution you can do, key distribution, QKD you can do, PQC some of it you can do, post quantum cryptography you can do it. Study sensing, Zeeman effect, some of physics teachers may be doing sensing. So this one, this is first part, optics part, communication part, and I think till that was physics, right? So this I think is physics part. This part is physics. Maybe we can use another color. This is physics part, this is electronics part, right? Analog and digital electronic components, power supplies, VNA, CW, function generator, oscilloscope, spectrum analyzer, RF system on chip boards, microwave components, amplifiers, double balance mixers, IQ mixers, directional couplers, circulators, isolators, filters, cables, attenuators. Right, this part is all electronics. Okay, where is computer science? Software, na? So that is only simulators, and most of the simulators are open source. Penny is free, QSIM is free, QInverse is free, and Qiskit is free to run. But then when you want quantum time, you pay. It's a cloud based time. So whenever you are applying for projects, you can get the quantum time, right? So these experiments, some of your colleges may not be eligible this time, but next call, which will be for June 2026, to start the courses from June 2026, you convince your college to offer an elective. If you are AICTE affiliated college, AICTE already given permission. On those 11 courses, you can add any electives and start. You can start a minor course. You have to apply for permission, they will give permission. So target for next June. This is already July is gone, now you cannot start. December you cannot start. So let us target June. By June, try to set up this lab with your own college resources. Then you ask National Quantum Mission, we have these resources, we have spent some 60 lakhs, now you give us 1 crore. In that 1 crore also we will give 25 lakhs. College will agree. 75 lakhs NQM will give. Right? So the person is also Telugu man, JBV Reddy. He is the top guy in National Quantum Mission. JBV Reddy. So he will favor us. He is part of the AP State Council for Higher Education. They have set up a committee. He is the chairman of the committee. Right? So he will provide the resources. Now let us at least be ready to use the resources. Right? I hope. So nothing else is left. 75, yeah?
Sir, roll number में मन चाहिए college partnership का
25% ఉంటే చాలు. 75 lakhs they will give, 25 lakhs you have to give. It is written also, somewhere it is written. For central government institutions they will give free mostly. For other colleges which are private and private universities and state government, they will give some ratio. Right? So what I would suggest is you ask for more money and give half of the share. Because college is good, you can start minor course in quantum. Some of them are starting BTech quantum computing. Have you heard? Andhra University is starting. This year itself Andhra University is starting BTech in quantum computing.
What do you say on
Electronics department only.
what is your say on it? Students can be encouraged because
Now actually what they will do is mostly physics courses and electronic courses with few computer science courses will be merged. That's how they will run. Its electronics department is in Andhra University, electronics department is floating the BTech in quantum computing, which will be under electronics, but computer science people, physics and maths people will teach in that. So there will be combined courses, but few courses they will come from this thing. Some computer science courses will be there, like that.
so career opportunities for them can be
There's so many, it will be so many. Like AI, how today there are career opportunities. If somebody has a very good understanding, there is so much of requirement.
so gate might be introduced again in quantum in
Slowly gate will be introduced in quantum, yes. Like how data analytics is introduced now. Data analytics and AI is a new code which is introduced. And let me tell you, MNIT, we have opened selection in AI department. BTech can be in any branch. MSc, Maths, Physics, Chemistry is eligible to teach in AI department, provided they have a research, PhD they have done on some. So many are coming who have done on optimization, on they have used machine learning for getting the results. So MSc Maths, MSc Physics with PhD in Maths or Physics using AI, if they have done, they are becoming eligible. Earlier non-engineering, they were not eligible for engineering departments, but AI department we have opened. IIIT quota is also following the same line. So you can, the ads are come, you can check that out. So similar to this, MSc Physics, MSc Maths and BTech Electronics, MTech Electronics will be open for computer science specializations. Many of you can opt, if you start teaching quantum courses, many of you can slowly move to computer science department or electronics department, which will offer quantum courses, right? Because teachers will not be there, right? The target of Chandrababu Naidu sir is within these 6 months, he want to train 50,000 students. Who will train? 50. Like even if you have 100 students in each class, there must be 5,000 teachers who will teach. So he is conducting 500 train the trainer programs, which are going to happen shortly. IIT Madras and IIT Kanpur, they have taken the initiation. They will employ. They can't teach, so they get the project. They will employ others to teach. So some of you can teach if you do the course. If you prepare, those 3 courses are readily available. You finish the course, you can become eligible for those things. They are all coming up. Quantum train the trainer programs you can apply. You will be invited to that institution, either IIT Madras, but you have to spend 1 month, pass the exam. A lot of these things are there, right? After finishing 6 courses, what we are doing now, we are going to offer a face-to-face meeting. IBM will conduct that face-to-face meeting for 3 days. One of the day they will write the exam, and those who pass the exam, they will be certified as IBM educators. So they can be trainers. So all these efforts are going in that line. What I open to you is a window which nobody is exploring. Everybody is thinking somebody will set up the lab, I will use the lab. Right? You all are shocked after listening to that. I don't understand many of that, but what I am trying to bring it to you is some of the words will strike to you. Right? I have not set up, I have not seen those setups, but you know those setups. Now you start there and build up. Right? That's my story. One of the Madam Anindita Banerjee, who wrote the syllabus also, she recently finished PhD on quantum related. She joined CDAC at a lateral entry. Now she is an authority and she is giving so much of content. Last 3-4 years. One boy I met in the QPAI company 5 years ago, he was BTech in Lucknow, one government engineering college. He went for internship somewhere. There he got the quantum concepts, and after that company took him and he started working with this QPAI. And today he is the, Chief Technology Officer, 5 years after BTech. Opportunities are there. If you are willing to work hard, then things are going to open up. Not only work hard, work together. So few universities you have come together, so 3 or 4 of you, please work together, and then we will be able to achieve the thing. So any other questions? Qiskit programming and using Qiskit, the 10 minutes hardware, if they can run on that, because my student, I forced him to run his code on quantum computer vision. He wrote some quantum code which he ran on Qiskit. So I said, you run it on the quantum hardware, connect to that 10 minutes quantum time, use not the simulator. Simulator will run on classical computer. The code will actually run on quantum hardware in that 10 minutes time, very less time. So within 3-4 minutes he could compile a result and show it. So he told that both the results I have got. అవును. రెండు separate tools. అది. So మీరు అదే, if you are able to do something on one particular platform, you have to convert your ఇప్పుడు మీరు ఏ ప్లాట్ఫామ్లో రన్ చేయాలంటే ఆ ఎన్వైర్న్మెంట్లోకి తీసుకెళ్ళాలి కోడ్ని. ఇక్కడ జావా స్క్రిప్ట్ కోడ్ని పైథాన్లో కన్వర్ట్ చేయాలి. Like morning I was discussing with one ma'am, she was also telling about network simulator script she is writing, but after running it on classical, when she wants to run on quantum, she has to convert the code to Python. So these are interfaces. QSIM has one interface, Pennylane has one interface. So mostly Python. So that's why you start with Python. So these are all very much accessible and able to do. So I hope you will do your best. I think, yeah, we are now time for only questions. Anybody if has any questions, we can.
క్వాంటమ్ కంప్యూటర్ని సూపర్ కంప్యూటర్స్ పవర్ కంటే ఎక్కువ ఉంటుంది. అంటే ఇప్పుడు క్లాసికల్ కంప్యూటర్స్, సూపర్ కంప్యూటర్స్,
లే ఇప్పుడు నువ్వు టు సర్టన్ రేంజ్ ఆఫ్ గ్రాఫికల్ కంప్యూటేషన్ జీపీయూస్లో చేయగలిగింది దానికంటే కొంచెము విల్ బి స్లైట్లీ బెటర్ ఇన్ క్వాంటమ్. బట్ ద పవర్ ఆఫ్ ఎగ్జాస్కేల్ వెన్ యూ కంపేర్ ఎగ్జాస్కేల్ విల్ క్వాంటమ్, రైట్? క్వాంటమ్ రియలైజబుల్ things are less. But if you have a quantum realizable kit, definitely it will be faster than exascale. So you compare, you can read, compare exascale with quantum. Why is quantum pushed now? Is because exascale has come to a limitation. అంటే ఆ స్పీడ్ పెంచుతూ ఉంటే ఇంకా చిప్పు కాలిపోద్ది. సో చిప్పు కాలకూడదంటే క్వాంటంలోకి మూవ్ అవ్వాలి. ఒక స్కేల్ తర్వాత సిపియూ రన్ అవ్వలేకపోయింది. సో ఇప్పుడు బ్లాక్ చైన్ రీసెర్చ్లో నేను చేసినప్పుడు ఇనీషియల్ ఒక సిపియూతోని ఒక బ్లాక్ క్రియేట్ చేయగలిగేవాడు. తర్వాత జీపీయూ వచ్చింది, క్లస్టర్ వాడేవాళ్ళు, క్లస్టర్ ఆఫ్ సిపియూస్ వాడేవాళ్ళు. తర్వాత జీపీయూ వచ్చింది, తర్వాత క్లస్టర్ ఆఫ్ జీపీయూస్ వాడేవాళ్ళు. తర్వాత ముగ్గురు నలుగురు కలిసి ఒక పూల్ క్రియేట్ చేసి వాళ్ళ పవర్ వాడేవాళ్ళు. అది అయిపోయిన తర్వాత అప్లికేషన్ స్పెసిఫిక్ ఇంటిగ్రేటెడ్ సర్క్యూట్ ASICs క్రియేట్ చేశారు. ఇప్పుడు ASICs వాడుతున్నారు. ASIC రెసిస్టెంట్ మైనింగ్ అల్గోరిథమ్స్ వచ్చినాయి, అల్గోరిథమ్స్ కూడా మార్చారు వాళ్ళు, ASIC రెసిస్టెంట్ చేశారు. సో దీని దగ్గర ASIC ఉన్నా కానీ అంతే టైం పడుతుంది, సిపియూ ఉన్నా కానీ అంతే టైం. అలాగా ఇప్పుడు క్వాంటమ్ రెసిస్టెంట్ రాలేదు ఇంకా. ఇప్పుడు క్వాంటమ్ వస్తే బ్లాక్ చైన్ బ్రేక్ అవుద్ది కోడ్, అది భయం అందరికీ. సెక్యూరిటీ బ్రేక్ అవుద్ది. మనం ఆర్ఎస్ఏ వాడతాం హ్యాపీగా కంఫర్టబుల్గా, మన క్రెడిట్ కార్డ్ ట్రాన్సాక్షన్స్ అన్నిటికీ ఆర్ఎస్ఏ వాడతాం, నో ప్రాబ్లం. క్వాంటమ్ రియలైజబుల్ చిప్ చైనా వాళ్ళది ఉంది కదా, అది కొన్ని అల్గోరిథమ్స్ని బ్రేక్ చేసింది.
అంటే 2 qubit క్వాంటమ్ కంప్యూటర్ని ఇప్పుడున్న సూపర్ కంప్యూటర్తో కంపేర్ చేయొచ్చు సార్. కంపేర్ చేయడం దానికంటే
ఫుల్ సూపర్ కంప్యూటర్తో లేదు, మనం వాడే సూపర్ 2 qubit ఈజ్ నథింగ్, 25 qubit ఈజ్ ఆల్సో నథింగ్, రైట్? బట్ 25 qubit విల్ బీ డెఫినెట్లీ కంపారబుల్లీ పవర్ఫుల్ దాన్ దట్. బట్ నువ్వు అన్ని అప్లికేషన్ అంటే టుమారో వెన్ క్వాంటమ్ కంప్యూటర్స్ కమ్, విల్ ఐ రీప్లేస్ సిపియూస్? నో. సో ప్లీజ్ అండర్స్టాండ్, మన క్వాంటమ్ దేనికి వాడతామంటే ఎక్కడైతే సిపియూస్ చేయలేకపోతున్నాయో అక్కడ తీసుకెళ్తాం. అంటే ఇట్ ఈస్ లైక్ ఎ తోప్. నువ్వు పిస్టల్తో పేల్చగలిగింది పిస్టల్తోనే పేల్చాలి, ఎప్పుడు నీకు పిస్టల్స్ అవసరం. అంటే సిపియూస్ విల్ ఆల్వేస్ కంటిన్యూ టు బి దేర్. బట్ కొన్ని నీకు పెద్ద వర్క్ చేయాలి, అది పిస్టల్స్తో 100 పిస్టల్స్తో కూడా అవ్వట్లేదు, అప్పుడు నీకు తోపు కావాలి, ఆ తోపు పెట్టి వీల్ ఫైర్. సో వేర్ ట్రైన్ ఈజ్ నీడెడ్, ట్రైన్ ఈజ్ దేర్. వేర్ బస్ ఈజ్ నీడెడ్, బస్ ఈజ్ దేర్. వేర్ కార్ ఈజ్ నీడెడ్, కార్ ఈజ్ దేర్. సో ఈ కార్ యొక్క యూజ్ ఎప్పుడు ఉంటుంది, సిపియూ క్లోజ్ చేసేది లేదు. క్వాంటమ్ రియలైజబుల్ కాదు, అంత ఈజీ కాదు. ఇట్ వోంట్, నేను స్టోరీలా చెప్పాను కానీ 1 yearలో అంటున్నాను కానీ 2-3 years పడుతుంది. ఈరోజు స్టార్ట్ చేస్తే డబ్బులు ఇచ్చేసిన మనం అంతా ప్రాసెస్ చేసి దాన్ని టెస్ట్ చేసేటప్పటికి 2-3 years పడుతుంది. సో ఇట్ టేక్ సమ్ టైం. బట్ ఇండియా ముందుకు వెళ్ళాలంటే ఈ బస్సు మిస్ అవ్వకూడదు. ఏఐ బస్సు మిస్ అవ్వలేదు, చాలా మట్టుకు మనం ఒక రేంజ్కి వచ్చాం. ఇప్పుడు క్వాంటమ్ బస్సు తొందరగా పట్టుకుంటే మనం వీ విల్ బీ అట్ పార్ విత్ ద వరల్డ్. ఎందుకంటే ఆపరేటింగ్ సిస్టమ్ గురించి కానీ ప్రాసెసర్ గురించి కానీ ఏది కావాలన్నా మనం వీఆర్ డిపెండెంట్ ఆన్ అదర్ కంట్రీస్. మన కంట్రీలో లేవు, అది ప్రాబ్లం. అందుకనే మార్కెట్, వీఆర్ గుడ్ మార్కెట్ ఫర్ దెమ్. మనం క్రియేట్ చేస్తే వీ విల్ లీడ్ ద నేషన్, వీ విల్ లీడ్ ద వరల్డ్. దట్ ఈస్ ద క్వశ్చన్.
సార్ ఎక్సెల్లో కూడా ఎంటర్టైన్మెంట్ ఉంది కదా సార్?
ఎక్సెల్లో
కూడా ఎంటర్టైన్మెంట్ ఉందండి. ఎందుకంటే ఒక వాల్యూ మారిందనుకోండి ఫార్ములాలో, ఆటోమేటిక్గా ఆ ఫార్ములా ఎక్కడ రిపోర్ట్ అవుతుందో అన్నీ మారుతాయి.
అది పవర్ ఉందిలేండి. అంటే బేసికలీ వన్స్ యూ నో హౌ టు యూజ్ ఇట్ దెన్ యూ హ్యావ్ ద పవర్. సార్ ఎవరో అడిగారు సిలబస్. ఇప్పుడు ప్రస్తుతం అయితే ఏఐసిటీది సింపుల్గా ఉంది సిలబస్. అంటే మీరు ఇప్పుడు ఆదికవి నన్నయ్య యూనివర్సిటీ కంటే కొంచెం లోలో పెట్టారు, ఎందుకంటే ఏఐసిటీ కాలేజెస్ని టార్గెట్ చేశారు వాళ్ళు, వాళ్ళ కాలేజెస్కి రాశారు. అందుకని ప్రతి దాంట్లో ఇంట్రడక్షన్ అనే వర్డ్ ఉంటుంది. నేను మా కోర్సులో అన్నింటిలో ఇంట్రడక్షన్ అనే వర్డ్ లేపేశాను. మీరు చూస్తే సిలబస్ ఇట్ విల్ బీ ఆల్ ఇంట్రడక్షన్ అని ఉంది అక్కడ, మీరు చూడొచ్చు. ఏదది ఓ సిలబస్ పెట్టి ఇక్కడ ఉంది. ఇది చూడండి, ఇక్కడ కోర్సెస్లో ఇంట్రడక్షన్ టు క్వాంటమ్ కంప్యూటేషన్, ఆల్ ఈజ్ ఆర్ ఇంట్రడక్షన్స్. సో ఇంట్రడక్షన్ ఈజ్ ఏ వెరీ సింపుల్ వర్డ్. సో కొంచెం తక్కువ ఉంది. మీరు మీ యూనివర్సిటీ కస్టమైజ్ చేసినప్పుడు, ఇప్పుడు ఏపీ గవర్నమెంట్ కూడా చేస్తున్నప్పుడు వీఆర్ ట్రైంగ్ టు స్కేల్ అప్. సార్ రైట్ సార్, డైరెక్ట్లీ వాడచ్చు. మీది ఏ యూనివర్సిటీ మీది?
RGP సార్, రిజల్ట్ RGP.
మీరు ఆటోనమస్ కదా సార్, మీరు దీన్ని స్కేలప్ చేయండి. మీరు కరికులం ఆటోనమస్ కదా కాదు, మీరు యు ఆర్ నాట్ బౌండ్ టు ఎనీ యూనివర్సిటీ కదా. మీ కోర్సెస్ మీరే రన్ చేస్తారు కదా, మీది సిలబస్ మీది కరికులం మీదే ఉంటుంది కదా. మీరు కరికులం డెవలప్మెంట్ వర్క్షాప్ చేసి ఈ సిలబస్ని కొంచెం స్కేలప్ చేయండి.
డిగ్రీ కాలేజ్ అటానమస్ అయితే ఇంప్లిమెంట్
చేసుకోవచ్చు.
డిగ్రీ కాలేజ్ అటానమస్
ఇప్పుడు ఏపీ స్టేట్ కౌన్సిల్ ఫర్ హైయర్ ఎడ్యుకేషన్ కన్సల్ట్ అవ్వండి. వాళ్ళు దీన్ని కొంచెం ఇంప్రూవ్ చేసి సిలబస్ ఇవ్వబోతున్నారు, మీరు చేయొచ్చు. ఇప్పుడు
ఇదే సిలబస్ మేము ఆల్రెడీ యూనివర్సిటీలో చూస్తున్నాం. నాకు ఏంటంటే మీరు ప్రొవైడ్ చేస్తున్న లిటరల్స్ని వాడుకోవచ్చు. వీడియోస్ ఉన్నాయి కదా డైరెక్ట్.
అందుకే కదా సార్ మేము చేసేది. ఏఐసిటీ రిక్వెస్టెడ్ అస్ ఇన్ఫార్మల్లీ మీరు చేయండి. అందుకని ఏఐసిటీ మాది లోగో వస్తుంది మా సర్టిఫికేట్స్లో. మేడం వాళ్ళు రిసీవ్ చేసుకున్న సర్టిఫికేట్స్లో ఏఐసిటీ లోగో, ఎన్క్యూఎం లోగో ఫస్ట్ కోర్స్కి ఇచ్చారు, మిగిలిన కోర్సులకి ఇస్తామంటున్నారు. అది ఇస్తే మళ్ళీ నేను అన్ని సర్టిఫికేట్స్ అన్నీ జనరేట్ చేసి ఇస్తాను. సెకండ్ కోర్స్, థర్డ్ కోర్స్ కూడా ఎన్క్యూఎం, డిఎస్టీ, మెయిటీ, ఏఐసిటీ అకాడమీ మెయిటీలో ఉంది, అండ్ ఐబిఎం. ఈ 5 లోగోలు కింద 7 లోగోస్ కలిపి ఉన్నాయి. నేను చూపిస్తాను, ఒక సర్టిఫికేట్ చూపిస్తాను. సో దే ఆర్ ఇన్వాల్వ్డ్ డైరెక్ట్లీ, సో యూ కెన్ లుక్ ఎట్ దట్. పైన లోగోలు చూడండి ఇవన్నీ. ఇప్పుడు ఈ కోర్సులు 6 కోర్సెస్ చేసిన వాళ్ళకి, 5 కోర్సెస్ చేసిన వాళ్ళకి వీఆర్ టైఅప్ విత్ ఏఐసిటిఈ పీజీ సర్టిఫికేట్ ఇస్తుంది. మీరు చూసుంటారు, పీజీ డిప్లొమా అనట్లేదు, పీజీ సర్టిఫికేట్ అంటుంది 5 కోర్సెస్ చేస్తే. సో మేమేమంటాం అంటే మా 5 కోర్స్ చేసిన వాళ్ళకి మా 5 సర్టిఫికేట్స్ ఇస్తే మీరు వాళ్ళకి పీజీ సర్టిఫికేట్ ఇష్యూ చేయండి అని మేము రిక్వెస్ట్ చేస్తాం. ఏఐసిటీ అకాడమీ ఎలాగో ఇస్తుంది, 5 కోర్సెస్ చేయగానే వీ విల్ గివ్ అవర్ పీజీ డిప్లొమా. కానీ ఏఐసిటీ సర్టిఫికేట్ తీసుకుంటే మనకు బెటర్ కదా. సో వీఆర్ లుకింగ్ ఎట్ దట్. సో మోస్ట్లీ ఐబిఎం ఆల్సో వాళ్ళు కూడా మాట్లాడుతున్నారు, బాగానే జరిగినాయి సార్, కోర్స్ అంతా బాగానే కండక్ట్ అవుతుంది. కాబట్టి ఇప్పుడు మీరు ఎనీ టీచర్ వాంట్స్ టు టీచ్, డైరెక్ట్గా ఆ కోర్స్ ఫస్ట్ కంటెంట్ తీసుకొని డైరెక్ట్గా మీరు స్టార్ట్ చేయొచ్చు. సో దీస్ ఆర్ ది ఆప్షన్స్. ఇలాగా 1000 ఆల్ స్టేట్స్ కలిపి మన ఏపీ నుంచి చాలామంది ఉన్నారు, మ్యామ్ వాళ్ళు చేశారు. సో అలాగా. సో నెక్స్ట్ కోర్సెస్ మీరు చూడండి. మళ్ళీ సైకిల్ ఇంకోటి స్టార్ట్ చేయడానికి ట్రై చేస్తాను, QT01 నుంచి మళ్ళీ స్టార్ట్ చేయడానికి ట్రై చేస్తాను, డిపెండింగ్ ఆన్ ద డిమాండ్. తప్పకుండా, షూర్ సార్. అదే ఇది ఒకటి రన్ అవుతుంది కదా, దాంతో మళ్ళీ ప్యారలల్ అంటే అంత లోడ్ యాక్చువల్గా. ఇప్పుడు 1000 మెంబర్స్ క్వెరీస్ వాట్సాప్లో హ్యాండిల్ చేయాలంటే హెక్టిక్ అనమాట. అది నడుస్తుంది, చేస్తున్నాం, పర్లేదు. సో ఫార్ సో గుడ్, ఎవ్రీబడి ఈజ్ హ్యాపీ. చేస్తున్నాం, మూక్ క్రియేట్ చేస్తున్నాము. మూక్ క్రియేట్ చేసి ఈ వీడియోస్ని క్యూరేట్ చేసి అన్నీ కట్ చేసి ఎడిట్ చేసి చేస్తున్నాము. ఎన్పిటెల్ లాంటిది వీ విల్ ఆఫర్. దాని తర్వాత ఇది కొంచెం టఫ్ ఉంటుంది, ఎందుకంటే మీరు క్లాస్ అటెండ్ అవ్వట్లేదు కదా, వీడియోస్ విని మీరు ఎగ్జామ్ రాయాలి. కాబట్టి ఎగ్జామ్స్ విల్ బీ స్లైట్లీ టఫర్ దాన్. పర్లేదు, ప్రిపేర్ చేసి రాయొచ్చు. సెకండ్ ఆప్షన్స్ కూడా ఇస్తాం, ఒకసారి ఫెయిల్ అయితే మళ్ళీ రాయొచ్చు. బట్ దెన్ ఫైనల్లీ విల్ సర్టిఫై. సో ఆ స్కేల్ స్టార్ట్ అవుతుంది. ఆల్ దీస్ కోర్సెస్ విల్ కమ్ ఆన్లైన్ విద్ ఇన్ నో టైం. సో నా మోటివేషన్ ఏంటంటే హార్డ్వేర్ వైపు ఆలోచించండి, ఎస్పెషల్లీ ఫిజిక్స్ అండ్ ఎలక్ట్రానిక్స్ ఫ్యాకల్టీ. రైట్, థ్యాంక్ యూ సో మచ్.
Thank you very much, Dr. Emmanuel. We ended the FDP technical sessions with another great lecture by Dr. Emmanuel, and you have heard from his words the contribution he is doing through training teachers. And today's session is totally different from what was covered earlier. How to set up labs, definitely this is helpful for all of us. PPT will be shared, and any doubts, I don't think he can give time, because once you join that course, you come to know how much. Even I should say sorry for troubling you by inviting you here. I felt that because it is very, very like tightly packed schedules, but I felt like because he has visited Kitty's house, his cousin, so and my brother, so I thought, okay, let it be some change of place, change of people and everything. That will be a bit relaxing. Anyhow, thank you. Big thanks from ATAL FDP team of Nannaya University for your time and your motivation for me. Definitely, I wish to reach your level at least. Thank you. Thank you very much. Small felicitation from us. I invite Tadapalligudem campus faculty, Swami Garu and Apache Garu, to felicitate our speaker today.